protocol, the CSMA-CA, which supports two type of MAC sublayers, right? This MAC function has two sublayers, one for the streamy traffic and another for the to support the busty traffic, because in a network all stations do not have the similar traffic characteristics. They do not belong to the similar traffic characteristics, because some of the stations have a lot of data to send and receive. Some other stations have only very smaller data to send. So in that way, seeing the varying range of station requirement, this MAC layer protocol supports two type MAC sublayers. One is for streamy traffic, another is for busty traffic, right? So we will see it in wireless LAN. Once we enter into wireless LAN, at that time we will see that. Now coming to another MAC protocol, as I told you that from this category we finished this random access, right? Random access or contention based protocols. Now going to this channelization, you have already studied in your digital communication. So we are not going. Polling, you studied in data communication, right? Roll call polling, hub polling, right? And this token passing scheme we will be concentrating next. So when I am saying token passing, there are three options where the token is used to control the access in a in a ring network, right? In a ring topology. One is called as a token ring, another is a token bus, right? Token bus is not in your syllabus. It is token ring is your IEEE 802.5. This this token ring. This token ring is IEEE 802.5 and this is IEEE 802.4 token ring, right? So, and then fiber distributed data interface, FDDI, right? So we will start with token ring. Okay. As you know that what is the meaning of a token ring? We know that in a ring, the stations are connected in this fashion, right? Suppose there are four stations A, B, C, and D, right? There are four stations. So who will transmit on the ring? How we will decide who will transmit on the ring and how long it will transmit, right? So to keep a fair distribution among the stations, a free token, basically in this a frame which is called as a free token passes in the ring. जैसे आप जाते हो ना, जैसे you go to the hot and cold or any place, they give you a token, right? You pay it, they give a token, and once your turn comes, you go and collect the order, right? चाहे आप मैकडी में जाओ या कहीं पे भी जाओ. So like that, similarly here also, whoever grabs the token will have an opportunity to transmit, right? So initially a free token, because someone has to launch a free token in the ring. So initially a free token moves around in the ring and the station with then there comes many things like priority comes, right? Who has the priority among stations, who will transmit first. So let us keep it simple first initially and discuss it. Suppose station A grabs this free token, right? So there are mechanisms that this free token, once A grabs this free token, when that token is moving in the ring, A grabs it and make it as a busy token. Okay, because token is nothing but a frame. Frame means some sort of bits, right? Like a continuous stream of bits. Okay, some pattern of bits. That is called as a free token. So once a station grabs it, it alters the pattern of the frame to make it a busy frame, busy token, right? So initially a free token circulates in the ring. The station which grabs the token convert it into a busy token and starts transmitting its frame. Okay, so you can see, so a small frame called token allows for access over the medium. So as you can see, a free token is moving in the ring, right? Now A grabs this token. After grabbing it, A starts transmission for station C. A sends a frame for station C, right? So once the frame reaches station C copies the frame, okay, and then regenerates the bit pattern as you know. So once this goes back to A, right? Once it goes back to A again, okay, the transmitted frame reaches back to A. It, or if it wants to send more number of frames, it can send more number of frames, and then once it completes its transmission, okay, transmission will be completed only when the frame reaches back to the sender, and once it reaches back to the sender, the leading edge of the frame reaches back to the sender. It serves as an acknowledgement that the frame has been delivered successfully. So this frame has to be removed by the transmitting station, and at the same time, after doing it, it regenerates a free token in the ring, right? So once it regenerates the, so now when the token will be released, when a new token will be released, either the station has completed its transmission, okay, so that will depend on the bit length is less than frame length or bit length is greater than frame length. I discussed this part earlier, that if the bit length signifies that how many number of bits can be present on a ring network, right? So that tells me the bit length. So if bit length is smaller than the frame length, okay, so that means what will happen if the bit length is smaller than the frame length? Can you say? Can you say what will happen if the bit length is smaller than the frame length?
The acknowledgement will come before it transmits all.
Yeah, not, you should not say acknowledgement, but you should say that it will start receiving its own transmission before it has finished the transmission of that frame. जैसे मान लो अगर A transmit कर रहा है and if the frame length is higher, then what will happen? This A will keep on transmitting and at the same time it will start receiving its own transmission, right? So the leading edge of the frame will reach back to station A. So in that way, the bit length is smaller than the frame length. So in that case, the station will release the token, new token in the ring once it receives the leading edge of the frame. Okay, once the leading edge of the frame reaches the station, it will issue a new free token. Okay, if the bit length is less than the frame length, but there can be other way also. If the bit length is higher than the frame length, so immediately after its transmission is over, it will generate a new token. Okay. So can you say in a simple term that what is the advantage and disadvantage of this scheme?
Sir, no collision.
Advantage you are saying, okay, fine, no collision. Dedicated point-to-point link, so data transfer will be faster, secured, right? Throughput will be higher. Okay, throughput will be higher when in a high load conditions where all the stations have data to send. Otherwise, what will happen? If it is under light load conditions, it will not give. It will the working will not be that effective because the stations will simply pass their turn. If they do not have sufficient data, if they do not have data, they will simply pass their turn. They will not grab the token, and the token will keep on circulating in the ring, right? So that is one possibility. And any other disadvantage? Any other disadvantage?
Sir, if the link breaks, the entire circuit is compromised.
That is the disadvantage of a ring. Now I am asking this token ring का कोई disadvantage बोलो. See, you tell me that if suppose this token, who will there is a possibility that the two tokens are circulating in a ring. A duplicate token is also possible because suppose one station has generated a token and some other station has also found when some station has grabbed a token and the other station do not find it, a new token can be generated and a duplicate token can also be circulated, or a token is missing in the ring, right? Token can be missing in the ring. The station has not issued a free token even though it has ceased its transmission, but a new token has not been released in the ring. So this type of issues basically this type of issues requires a token maintenance, right? So to overcome the issue of duplicate token, or if token is not there, a new token is to be introduced in the ring. So to take care of all these things, we require a station which serve in the capacity of a monitor station, okay, and it is responsible for token maintenance. So the token maintenance will be the responsibility of a monitor station, right? So that if in any case if there is no token circulating in the ring, it is to be generated by the station, or if a token is more than one token is circulating, one token needs to be seized, right? So if I had to say about the token ring MAC frame, एक minute. Okay, so this is a MAC frame for the token ring. You can see the frame is shown over here. So here we have SD. SD is called start delimiter, and there is ED. ED is called end delimiter. So basically, this start delimiter and end delimiter. Start delimiter means it indicates start of a frame, right? These are basically used for the synchronization purpose as DED. These are used for the synchronization purposes to synchronize between a transmitter and a receiver. And SD is called as a start delimiter. So it's nothing but it is coded as it is basically a combination of non-data symbols like this JKO, JKO, like that. So this is a type of encoding scheme which mark the beginning of a frame, right? And AC stands for access control, right? Access control, you can see over here, this is access control. So in the access control, there are 3 bits for the priority, right? So with 3 bits you can have, so this will say about the priority of a token, right? So these are the reservation bits. 8 levels of reservations are possible. Similarly, 3 bits for priority that can result in 8 levels of priority. T is called token bit. If this is 1, it is a frame. If it is 0, it indicates whether it is a token or a data frame. So if T equal to 0, it's a token. If it is 1, it is a frame. M is used to, M is called as a monitor bit. So this is used to, like as I told you that uh, prevent basically persistent data token maintenance purposes, right? Then we have a frame control FC. This indicates whether this is an LLC data frame, means higher layer data frame, user data frame. So I hope you must be knowing that suppose this is one application layer, then you have a transport layer, then you have network layer, then data link layer mein it is divided like I will have it, I think. Okay, I'll say this is LLC. Then we have Mac. We have physical layer. कैसे होता है देखो, this is an application layer, there is a user data in the application layer. So once this user data, how does it work? It is passed down to the lower layer. Okay, whenever you want to transfer some data, how does it work? ये आप लोगों ने पढ़ा होगा, लेकिन मैं फिर से बता दे रहा हूँ. User data is passed down to the lower layer. So once it comes to the transport layer, what it does in this user data, okay, this is user data, it puts a transport header. What is there in the header? There is a port number, means socket address. I told you, at the transport layer we say it as a socket layer. Socket address, IP, combination of an IP address and port number for that particular process running on a port. So that particular application. So transport header, user data. So it adds a transport header, and then so once it adds a transport header, it becomes a segment. Right? It is called as a segment. The entire thing is called as a segment. And then what transport layer does? It provides an end-to-end error and flow control, end-to-end data delivery with error and flow control, right? So in order to do that, in order to accomplish that, it passed down this for routing purposes to the lower layer, network layer. Once it comes to the network layer, this entire thing, okay, becomes a user data for it. And what it does, it adds a IP header to it. What is there in the IP header? IP header means there will be a end user source address, source IP, destination IP. What is the size of the datagram? It is called as a datagram, right? And what is the size, this CRC, everything will be a part of this IP header, right? And then this data, along with IP header, this datagram is passed down to lower layer, LLC. So this becomes a user data. This whole datagram becomes user data. This, and it adds its LLC header. LLC header includes, we will discuss LLC logical link control. It basically provides different types of services. Because network layer is routing between two end users. Then it passes down to LLC for routing between the two nodes, right? So LLC provides three types of services: connectionless, connection oriented, and acknowledged connectionless, right? So which type of service you are using and all those things, LLC user address, destination address, all will be a part of this LLC header. And then this entire thing comes down to the MAC layer, where this is called as a user data. And in that, the MAC header and MAC trailer is added. Why MAC header and MAC trailer both are added, I will explain, right? So in this, and then it is passed down to the physical layer, and it follows in the bit stream, right? Data travels in the form of bits. So there is the framing and deframing is done. So at the MAC layer, once it reaches to the other system, at the MAC layer, it reads the MAC header and MAC trailer. So these fields are stripped off, and then it passes the data to the LLC, user data. So then the user data, it is called as a frame here, right? Frame. And the link layer, it is called as a frame. So it passes to where the MAC header and MAC trailer are removed. it reads and passes to the LLC user. LLC removes the LLC header, passes to the network layer. Network layer removes the IP header, passes to the transport layer. Transport layer removes the transport header, passes to the particular application. Like this it works, right? आपने पढ़ा होगा OSI model में. It works like this. Okay. Why I said now this? Because we were discussing about frame control. So frame control says whether it is a MAC frame or it is a MAC means it is a control frame, because MAC is this frame, or it is a user data or the LLC frame, right? So this AppC dictates about the frame control. Whether it is a MAC frame or a LLC data. Destination address, source address, data unit. Okay, if it is a MAC frame, data unit will be 0. Frame check sequence for checking the frame. And delimiter to mark the end of a frame. It is once again a non-data symbols. Frame status. Okay, frame status means it is copied fully. It has 3 things. Frame status, that I can say, yeah, frame control. Frame control is frame bits. 00 means MAC frame, 01 means LLC frame, and these are the control bits. Okay. And delimiter is again a non-data symbols, and I indicates intermediate. It's an intermediate frame, or it's the last frame. So if this is high, that says it is an intermediate frame. There are more to come, right? More frames to follow. E bit is an error bit. This bit can be set by any station that detects an error, FCS error, non-data symbol, any kind of error. That particular bit will be set by the station. And this is the frame status. So you can see here, these bits are reserved. RR is reserved. Okay, A is address recognized bit, C is a frame copied bit. So if A is 0, C is 0, that means address doesn't found. If address is not found, the station is not found on the ring, so it is not copied. Not copied. Station does not exist. So if the station does not exist, if a station is not found, A will be 0, C will be 0. A1, C0 means station exists, but the frame is not copied. Maybe because of some error, the frame is not copied. Maybe the address is not recognized by the frame is so corrupted that the receiving side didn't recognize the frame or couldn't copy because of the error in the frame. And this is A equal to 1, C equal to 1. So that says that the frame is delivered successfully, right? So this says about the frame status in a MAC frame. Okay. So can you say what are the disadvantages of a normal thing? What things we didn't take care of? We didn't take care of any kind of priority scheme, right? Suppose obviously some stations may have higher priority data. They are handling some higher priority data as compared to the other stations. So they should be given more priority as compared to the other stations. So how the priority can be dictated? Okay. So there is a priority scheme in the token ring. We discussed this part now, There should be some mechanism that will dictate that some station with higher priority should be given more opportunity. So there are three priority bits and there are three reservation bits. See, the essence of this is like a station, a higher priority station can reserve the future token at its at the higher priority. जैसे होता क्या है कि suppose station the token will be given some priority. Okay, station is having some priority. So based on that, the station can while this token is moving, while the token is moving, what was the token? This is the token frame format. There is an SD field. SD is a start delimiter, ED is end delimiter, and this is access control. Access control says this part PP, TT, AM, RR. So when the token is when the token is moving in the ring, the stations can send their priority. Okay, can reserve the token at their priority level. Okay, suppose a station is having a priority of 3, so and it will see the priority of the token initially. That suppose if the priority of the token is 2, right, presently in the ring. So if it see that the priority of the current token is lower as compared to the station's priority, it can reserve the token at the higher priority level. Okay, so higher priority level, reserving it at a higher priority level means if this station has the highest priority, only this particular station will get the token, right? So the reservation can be made at the priority level of a station by setting these bits in the token itself. Okay, while the token is moving in the ring, the station can reserve their token for future slots, right? So the scheme works. PF is the priority of the frame to be transmitted by the station. So PF is the priority of the frame to be transmitted by the station. PS is the service priority, or you can say the priority of the current token. Okay, so if the priority of the frame to be transmitted by the station is higher than the current priority of the token, it can reserve the future time slots. It can reserve the token, okay, at its own priority level. So how PR is the value of PS, current token, in the last token received by this station. तो जो अभी उसको जो प्रायोरिटी मिला है उसके बेसिस में, then what is RS? Reservation value in current token. RR is the highest reservation value in the frame received by this station during the last token rotation. Because the token is rotating now, circulating in the ring. If a station grabs it, then it regenerates it. So at what priority level it is regenerating it? So how does it work? A station wishing to transmit must wait for a token with priority, current priority of the token. So station can book a token if its frame priority is higher than the priority of the current token. So while waiting, a station may reserve a future token at its priority level, PF. If a data frame goes by and if the reservation field is less than its priority level. So if the current reservation in the token is less than the priority of the frame to be transmitted by the station, then the station may set the reservation field of the frame to its priority level. Okay, तो अगर करंट रिजर्वेशन जो है अगर वो उसका प्रायोरिटी लेवल कम है फॉर द स्टेशन जो वो फ्रेम ट्रांसमिट करेगा उसका प्रायोरिटी हायर है, देन इट कैन ऑलवेज डू दैट. So if a token frame goes by and if RS is less than PF and PF is less than PS, then the reservation can be set to at this priority of the frame to be transmitted by the station. Are you following? Any doubt?
No, sir.
Okay, so this token ring में क्या होता है? This we have decided the priority and all, but this token ring, like, it leads to a ratchet effect. Can you say what is ratchet effect? Huh? See, what you have seen that in the priority scheme, हमेशा क्या होगा कि अगर कोई lower, if some lower priority token is moving, a station with higher priority can reserve the token at its own priority level, right? तो ऐसे करके क्या होगा, then no lower priority station will be allowed to grab the token. Is it clear or not? If I reserve a token at priority of 5, so all the station, suppose if 5 is the highest priority, so all the stations with priority 1, 2, 3, 4 will not be allowed to grab the token, right? And what will happen? The station, because after finishing, so the station has to, once it got the token, it has to reissue a token after its transmission is over. So what will happen? The station will issue a new token either at the same priority level or at the higher priority level. So if the current priority is 5, so after finishing, suppose A finishes its transmission, so it will issue a new token either at a priority level of 5, or if any other station has requested the token which has a higher priority than 5, will be issued a token at that priority level. Suppose if the 5 is the highest priority level, so once a station finishes its transmission, it will issue a new token at a priority level of 5. All other stations which have lower priority will never grab it. So what is the conclusion? This ring priority scheme leads to a ratchet effect, means driving it to a higher state and then leaving it there. So every time a station with higher priority grabs the token, issues it at its own priority, and then like that the priority level of the token keep on going up, and finally a stage will come that there will be no taker for the token because of its higher priority, because it has reached to such a high value that no one will be able to take it. Are you following? So this kind of effect is called as a ratchet effect. So what could be the solution for that? Are you following that when the station finishes its transmission, so it issues a new token, because in the token the reservations can be made. So a station can issue a new token either at the same priority level at which the token was circulating, or to a higher priority level for which the reservation has been made. So like that, if the station issues a token at a higher priority level for which the reservation was made, the priority of the token has increased, then next time the next station will issue a token either at the same priority level or the higher. So like that, the token priority is always going up, and finally a movement will come then when no other station will be having priority higher than that. So that will result in circulation of the token and there will be no taker of the token, right? So this is called as a ratchet effect. So what should be the solution for that? What should be the solution? The solution is that the station which is upgrading the priority of a token should be held responsible for downgrading the priority level. Suppose A is sending to C, D reserves the higher priority level, right? So what A does, A first finishes its transmission and issues a new token at a priority of D, right? So since D has the higher priority label, D grabs the token, it performs its transmission and issues a token, new token at a priority of D, right? But no other station has this much priority, so that they can grab the token and the token will keep on circulating. So what should be the solution to mitigate this effect? The solution is that the station should maintain two stacks. Two stacks are to be maintained by each station. That one stack to remember the lower priority and one stack for higher priority. So if a station, suppose A issued a token to a priority level of D. So A should remember that it has upgraded the priority to D, right? So A will keep a note of it in its stack. So it will take a note of it that it has issued a token at a higher priority level of D. And when it finds that the token is moving in the ring, right, there is no taker. So A is only responsible to downgrade that priority. So then A checks it and issued it at a lower priority level that was earlier, right? So like that, this issue is resolved. Are you following?
Yes, sir.
Like here it is like A is sending to B, D deserves the higher priority. Okay. So this frame goes back to D. A frame length is higher than the bit length. Then A generates, after it reaches the leading edge of the frame reaches, A generates a new token at higher priority and remembers the lower priority. So it generates a token at a priority level of D because D reserves the higher priority. So and it remembers the lower priority because it has got two stacks to remember that lower priority. And then D uses token and sends data to B. And after that, it issues a token at a priority of D because there is no other, because the station will issue a token either at the same priority level or at a higher priority level. So it issues a new token at the priority of D. And since there will be no taker of that because it's the highest priority, and once the station A will find that there is no taker, what A will do, A will capture and issue a token at lower priority level because this lower priority, because A has upgraded from L1 to LD, right? So A knows that what from where it was upgraded, so it take it back to this position. So there are two stacks used to store old values of token priority. SY used to store new values of token priority. So two stacks are maintained by each station. So for token maintenance, as I told you, there should be a monitor station uh, which takes care of the token. So if in case of any duplicate token or loss of a token, the monitor station will be held responsible. So how will make its presence known to everyone? So what the monitor station does, it periodically sends an active monitor present control frame. So it uses a valid frame timer that by making m equal to 1 bit, so basically what is the idea about this active monitor present control frame? To assure that the other stations that there is an active monitor on the ring. To detect a lost token condition, it uses a valid frame timer that is greater than the time required to traverse the ring, that is the propagation time plus some additional amount of time. Okay, the timer is reset after every valid token or data frame to avoid any lost token, right? What it does, it sets a valid frame timer and it gets refreshed every time. Okay, once with after this much time. Okay, when because the some movement of valid token or data frame passes by. So neither any data frame is passing nor any token is passing. What will happen? This timer will expire because it will not get refreshed. This timer gets refreshed every time a data frame passes by or the token passes by. So since neither, if the token is not there on the ring, no station can grab it. They cannot send the data, right? So how the monitor station will detect it? Monitor station keeps a valid frame timer, and that timer get refreshes every time a valid frame or a token passes by in the ring. So in the absence of a token, there is no data frame will circulate, and this timer will expire. And once this timer expires, the monitor issues a new token at a priority level 0. Okay. Another thing, if some frame is persistently moving in the ring, okay, so and if its monitor bit is set to 1, the monitor, when the frame passes by, the monitor sets the monitor bit to 1, and if that frame is persistently moving in the ring, it checks the monitor bit and identifies that the station has failed to absorb this frame. So the monitor absorbs the frame and transmits a priority 0 token. Are you following? There are 3 conditions for a token maintenance. First of all, to make its presence known, monitor sends an active monitor signal to all the stations in the ring. Secondly, to detect a lost token, it has a valid frame timer which gets refreshed every time a valid frame passes by or a token passes by. If the token is not there in the ring, this timer expires and the monitor issues a new token at a priority level 0. Similarly, if any frame is moving in the ring, uh, circulating in the ring, the monitor sets the monitor bit to 1. When the first time the data frame passes by the monitor station, it sets the monitor bit 1. And when again this frame reaches to the monitor and it checks for the monitor bit and it finds that the monitor bit is high. So that means the transmitting station has failed to absorb it. So monitor station absorbs the frame and issues a new token at priority level 0. So this is about the token maintenance. Can you say the disadvantage of this scheme? Huh?
Sir, disadvantage of token maintenance.
टोकन मेंटेनेंस नहीं, टोकन रिंग में क्या डिसएडवांटेज है? I told you 2 options. See, this is called as an early token release. There was a case when the frame length was higher than the bit length. तब क्या हो रहा था आपका? When the frame length is higher than the bit length, That means when the station is transmitting, okay, the leading edge of the frame reaches back to the station, and station can issue a token immediately. The leading edge of the frame reaches to the station, so a new token can be introduced in the ring. But see the other case, when the frame length is higher than, sorry, frame length is lower than the bit length, उस केस में क्या होगा? Even though station has finished its transmission, but it will not issue a new token in the ring until and unless the leading edge of the frame reaches back to the station, right? So during that period of time, the capacity is wasted. Like there can be, are you following? So this in this way, the potential capacity of the ring is unused. So how can it be made useful? That ETR, early token release, okay, that basically works on the same principle where the frame length is kept higher than the bit length, okay. So ETR allows a transmitting station to release a token as soon as it completes the frame transmission. चाहे उसको वापस जाए या ना जाए, जैसे ही उसका ट्रांसमिशन खत्म होगा, it will issue a new token. Can you say what is the disadvantage of this? If the station issues a new token before the leading edge of the frame reaches back to the station, so what could be the disadvantage?
सर सही से ट्रांसमिट हुआ कि नहीं वो पता नहीं चलेगा.
राइट, वो नहीं पता चलेगा. दूसरा क्या कि because some other stations may set the priority, okay, so at what priority it will release a token, so it has to issue a token at the same priority level, okay. Most recent one जो frame में था, the same priority it has to use for releasing the token, and it is not able to read the reservation bits of the frame, it has just transmitted. So there will not be any use of the reservation bits, because the station is issuing a token immediately following its completion of transmission. So it is not seeing the reservation bits and other things, so it doesn't know. So the reservation का कोई मतलब नहीं रह जाएगा. Then how the priority scheme will work, right? So that is the disadvantage of ETR. So priority scheme will be partially disabled in that case, because the station को अगर issue करना है token following its completion of transmission, it will issue a token only at the most recent used priority label, okay. So because without seeing reservation bits, how can it issue a token at the desired priority label? So the effect of ETR is, though it saves the potential capacity of the ring, but it partially disables the priority scheme, okay. So we will see in the next class the dedicated token ring. Okay, thank you. Any doubt is there? Any doubt?